it's me again. So, yesterday you noticed I'm into pretty formal computer sciencey stuff, and I wanted to show you what you can do with theoretical computer science and plants. So, I'm not going to dive too deep into it, but you can describe plant growth the way you describe human language, with a grammar. A plant is basically just a seed that grows. We start with a seed, we have one leaf, then we have a couple of leaves, and in the end we might have a tree. Every step of that growth is a legit plant. So we can describe that with so-called generative grammars. Generative grammars are grammars that generate sentences or other structures that can be interpreted into sentences or plants. If you want to Google that later, you should search for Lindenmayer systems or L systems. How does our grammar look like? We've got one thing that's called the axiom, that's the initial word or the seed of the plant in our case. And we have replacement rules that describe how the plant grows. This is a replacement rule. You replace every occurrence of the symbol on the left-hand side with the symbols on the right-hand side, not like it's written here, but the other way around. I'll show you. So on the left side we have rules for S, L, and R. Our first word is the S. In the next iteration we replace the S with ls. Then we replace the S in the new word and the L in the new word, and so on. So the word gets longer every step. This is not really a word yet. That's not a word that we can understand. But we can apply a transformation function that translates it into something that we understand. That might be actual human words, but also it can be plants. So you could write a function that draws this word onto Canvas, into A-frame or WebGL. So the theoretical foundation for that is the same, and the cool part would be how to translate it into a tree. And I want to show you one way to do it with Canvas and so-called turtle graphics, how they work. If you've never heard of turtle graphics before, just imagine a turtle with a pen. And the turtle with a pen is following directions. So for example, an S would mean draw a straight line, an L would mean turn left, and an R would mean turn right. So for that word we have here, first would be drawing a straight line, then we turn left, draw a straight line again, turn right, draw a straight line, turn left again, and draw a line. That's turtle graphics. And I'll show you how this is actually used by someone. There's a GitHub repository by Tom Brewer for Lindenmayer systems in JavaScript that has some nice code pens you can play around with, and also it's super accessible and super well documented. This is the first iteration, the first part of a tree. The grammar is here on the side. It's not super important how it looks like. It's a bit complicated if you've never looked at this before, but just to show you what you can do. You see that shape that goes just two lines up and one to the side, and from this shape the whole tree will grow. And I'll just show you by increasing the iterations that we're going, that we can actually draw a tree with that. And that's Lindenmayer systems. That's a way to describe plant growth with grammar.